Welcome back to another episode of Thinking Critically. Today, I am joined by Jacob Lund Fisker, who wrote the first popular blog on financial independence and extreme early retirement. As one of the progenitors of the F.IR.E. movement, that is, financial independence, retire early, his philosophy embraces a more responsible way of living beyond the wake, work, and consume cycle that encircles capitalistic societies today. His book, Early Retirement Extreme, which applies systems theory to personal finance, has sold over 40,000 copies. An astrophysicist by training, he retired at 33 and now focuses on practical aspects of individual adaptation to the impacts of energy resources and climate breakdown. Anyway, Jacob, thank you so much for joining. It's my pleasure to have you.
Yeah.
All right, wonderful. That being said, I am really interested in learning about how it is that you even became interested in science in the first place. So, before you got into the extreme early retirement aspect of your life, you were first a physicist. So I'm just curious to hear your journey to science.
Yeah. It's definitely not like a straight path from A to B. I tend to have like a 5-year planning horizon. But like initially, I think, as most kids my generation, I grew up wanting to be an astronaut, age 5, not a fire truck. Science specifically probably started when I got a subscription to a Danish magazine called Science Illustrated, which had just come out as like the first science magazine in the country at the time, as far as I'm aware. It was probably earlier ones, but that was like at age 9. So that was like a big spaceship on the front cover going to Jupiter. And I really wanted that magazine. And then my parents just started buying it for me. But like, I wasn't specifically interested in becoming a researcher at that time. It was more just about space travel, and my other interests were essentially Lego, electronics, and computers. So science. Yeah, say what?
So you were a bit of a nerd like myself.
Yeah,
as
like
a child. You were.
Like a nerd, it sounds like.
There's nothing wrong with it. I own that term.
Right.
Yeah, that's fascinating. So space travel was something that fascinated you as a child, and you said you had the electronics component as well. So I'm assuming that's something that kind of stuck with you then throughout middle school, high school, and then at some point you decided that you were going to go away to university, and you decided that you were going to go into science, or?
No, technically, my interests have always sort of come around in circles. I get interested in something, and then it gets exciting for a while, and then maybe I drop it and come back to it 5 years later. So for example, electronics stuff I've been doing on and off from time to time, and same thing with say like astronomy or astrophysics. In terms of career, I think it has a lot more to do with serendipity in terms of like you make a specific choice at exactly the right time to set you off on a different trajectory. So that's at least how I see the future, that you have a certain amount of pathways, right? But a very limited amount of critical junctures where some decision essentially affects everything. So in educationally, I was in I would say probably until about what would correspond to the 10th grade in the US system. I was pretty bored going to school. It was a very boring experience. So like in the Danish system, the priority is essentially on your personal like social development, getting along with others, not so much on like intellectual development. So basically your entire class of about 15 to 20 people trek along for like the first 9 years, and then you again track the same class for the next 3 years up to grade 12.
So you have the same classmates?
Is that what you mean? Everybody goes to the same classes at the same time with each other.
Okay.
That group, and so you're basically in with like what one could dismissively call like the general population, which means like lots of repetition. They're basically being taught to the average student, which means that those who are
I know. I heard very
yeah, right.
Yeah, I've heard very similar stories from bright people about how the general education system was just kind of
Yeah, it
a
was.
slog. It was very boring, and they just didn't fit in.
Yeah.
And yeah.
Yeah, so in practice, what that resulted in was me sort of like losing more and more enthusiasm with the school system or the schooling system. My parents once told me a story, sort of like in retrospect, I'd forgotten all about it, but like on my first day in school, apparently I asked the teacher whether we could get some homework, because that was like so exciting. And she hadn't planned anything in that regards, but then apparently told us that we could go home and practice the alphabet. So I spent the entire day just writing the alphabet. But nothing was essentially planned. So I was sort of like just doing the minimal there. I wasn't thinking about grades or anything whatsoever. Then what happened was that I think I was like in ninth grade, I got a modem. So that was in 1989. So that was like 240 bytes per second speed. But that meant you could get on the FidoNet. That was before the internet was really a thing. And in there, you essentially could meet other people who are sort of like nerdy or geeky enough to be able to get on the net. And there was this guy I started talking to in one of the science forums he called himself Mini Gauss, after the German mathematician. And he was talking about complex numbers and proving theorems and all that other stuff I essentially never heard about, because our math class was still about solving like, y equals ax plus b, isolate something, right?
Well, you were in ninth grade, so I'm assuming that complex analysis was not something
that was not a thing, right? But technically it could have been a thing, right? I mean, I understood what he was, I could understand what he was talking about, and this was like very interesting to me, instead of like, you always get this question, like, so son, what have you learned in school today? And my answer was always like, nothing, like we haven't really learned anything this year. Maybe like square roots were introduced, but we've just been practicing them for like 4 months now, right? So there's no like novelty in going to school in that sense, right? So basically the idea that had not occurred to me, because, kids are just handed off to school, right? And then they come back, and so it's sort of like an institutional setting, was that you could actually become responsible for your own education. So that happened around the 10th grade. So I kind of like so this Mini Gauss guy is pretty cool, and I want to be like that too, right? So I went down to the high school library and walked over to the science, the STEM section, and essentially started reading college level textbooks in physics.
Okay.
And that's essentially how I got into physics. I mean, because then in that sense, like career choice over there was not really focused on, does this have any like career prospects, or is there any income in this field? Is there any good job prospects? It was just like, you should just go study what you're passionate about. Because they just wanted to push students through the system, right? And if you study what you're passionate about, it's a lot more likely that you'll finish. So that's essentially how I became a physicist. So that's
it all started on the primitive internet by you said a German mathematician? He pushed you toward...
I mean, he was Danish, but like...
Oh, Danish mathematician.
Yeah,
okay.
his handle was Mini Gauss. Back then you had a...
Mini Gauss? Yeah, okay. That's funny.
Famous German mathematician. So
yeah. And then you started reading books in the library. That's funny, is I started reading physics books when I was in high school as well.
Yeah.
I was pretty bored with the educational system, but I did love my science classes.
Right, exactly.
I always did the best in my science classes. I didn't like my math classes, which is surprising, I think, for a lot of people, considering that I have a degree in math. Yeah. And you need to use a lot of math in order to do physics, but I never really appreciated mathematics. I think until I got to higher level mathematics, because I couldn't really understand why it was so important. Like I couldn't visualize anything. I just was kind of like manipulating equations and things of that nature. And I didn't understand like why it was so applicable to everyday life. Whereas with physics, I mean, the math came really, really easy when I could see it then applied to everything.
Yeah. I mean,
Because
in our case, when you start at the university, at the particular university, it's all different over there, depending on which one you go to. But the one I went to, you had to pick 2 majors in your first year, like immediately before you start.
okay,
And for me, it was mathematics and physics.
which makes sense. I mean, because you
Yeah,
use so
yeah.
much
I mean,
math,
they
that makes
sort of
perfect
together,
sense. Yeah.
right? It's the classic constellation. But you could
Yeah.
also pick like physics and chemistry was another popular one, and then there was like computer science could be one, and like mathematical economics. I think those were like the five things you could pick. And I kind of enjoyed sort of like the manipulation of equations, etc. You know, these kind of simple questions in high school. So I picked mathematics without knowing that the sort of like the more advanced level was theorem proof, you know, like endlessly, which I don't think I was very good at relative to other people, because that's just not how my brain is wired.
Yeah. I can relate, Jacob. So the mathematics that I enjoy the most is more of the applied mathematics, where like the complex analysis, the partial differential equations, the differential equations, calculus, things of that nature. But taking like advanced calculus, where you're actually, it's like theorem-based calculus, where you're learning mathematics from axioms or first principles, which is really important, right, if you want to do mathematics. But that type of mathematical, like pure math work, doesn't interest me as much. Right. And I'm not as good at it.
Yeah.
So I think that's why I was more drawn to physics and the sciences in general, is because I like to see things applied. Mm-hmm. But yeah, I can totally relate, and I understand what it's like to not be theory-based, but more of an applied, applied mathematics.
My math professor told me once, which he probably nailed it, in the sense that, well, you probably have talent, Jacob, but you're not rigorous enough to do this. It was always, I would prove something, and he would be, what about the special case, you know, like, but that never happens. What's my argument? And I could kind of see sort of the opposite when I was started in grad school and I started TAing people, and sometimes you would have mathematicians come in, and they would, I wouldn't say of course, but generally they would not give, you know, they wouldn't care about the physical aspects of the problems at all, so they would prove everything. And they were like, you know, go on, theorem proof almost, and then in the case that the charge of the electron converges towards 0, we have the following solution. There we go on. Dude, you know, the charge of the electron is what it is, right? You can't just set it to 0 in this special case of yours. That's no relevance.
So you're no longer representing reality. I mean, it might be interesting it might be interesting from a pure mathematical standpoint, right, to see what comes out, but at the end of the day, physicists are not interested in that, because those solutions don't represent the real world.
Yeah. So, the mathematics physicists commit tends to be like a lot more ugly than what mathematicians are willing to accept.
Yeah.
Well, yeah.
Well, the world is complicated, right? It's not as pretty as pure mathematics sometimes wants it to be. So, but anyway, that's really interesting. So then, okay, so you went into university, double majored in math and physics, and then at what point did you decide that you're like, you know what, I really enjoy this, I kind of want to go on to graduate school? Did you go the master's degree route and then a PhD, or did you go straight for the doctoral degree?
That again, that's sort of like university specific what you can do. But first I got a master's degree, and then I transferred to Switzerland, where I got my PhD down there. I think I had this idea almost all the way from the day I applied that I wanted to go into research. So I was always sort of like fighting in that direction. I remember specifically not wanting to go into industry, because I had these sort of like ideas about, you know, like Einstein and Heisenberg and Feynman walking around in the park and thinking of all these great thoughts, right? So I basically wanted to be that guy, right? But I will admit, I did not have a specific sort of like career goal, in the sense of then I need to get my PhD and then I'm going to do like the required 1.5 to 2 postdocs, and then I need to get a professorship there, and so on and so forth. I did not have that mapped out. So basically my end target was to get the dissertation.
Okay. Yeah. I'm curious, where in Switzerland did you go to school?
Basel.
I'm sorry?
Basel.
Okay, I'm not familiar, but
the ones that Bernoulli went to, and Euler.
Okay.
Yeah.
Very interesting.
Nietzsche was there for a while.
Nietzsche was the, okay.
Yeah.
All right. That's fantastic. I've always wanted to go to Switzerland, and actually at one point was looking at schools in Switzerland, but I've actually never made it to the country. It's definitely on my bucket list of places to go.
Right.
I would, yeah. When I was in France, a part of a it was supposed to be a PhD, because I was in for a stint in my life. I was really interested in renewable energy, and in particular nuclear fusion. And I ended up living in southern France for 7 months because I wanted to be a part of the ITER project, which I'm assuming you're familiar with. Anyway, and for those of you who are not familiar that are tuning in, ITER is an acronym for International Thermonuclear Experimental Reactor. And nuclear fusion is the process that powers stars. So you take essentially very small atoms and you smush them together and you get energy out in the process, which is the opposite of what we have now as far as our nuclear power plants, which is fission, where you take large atoms and then you break them apart into smaller atoms and then you get energy out. But anyway, fusion is still experimental, and they're building the largest one in France at the moment. I wanted to be a part of that project, and was supposed to be a PhD, but I was thinking about leaving, staying just for a master's degree, and then trying to go somewhere else. And I was looking at universities in Switzerland, because there's a lot of, as you know, very good universities in Switzerland. But that didn't work out. It didn't work out in general. I ended up leaving. But anyway, yeah, Switzerland, awesome. It's definitely on my bucket list of places to go. I mean, I've seen pictures of it. It just looks absolutely breathtaking. I can't imagine, being able to go to school there for a number of years. That had to be quite the view.
Yeah, and the language.
And the language. So were you in the French or German speaking portion?
The Swiss German part.
Swiss German, okay.
Right in the corner, the tri-state area, right between Switzerland, Germany, and France. You could,
okay.
From where I live, you could walk to France in, I think it was about 10 to 15 minutes walking.
Oh wow, okay, very close.
It would be a 20-minute walk.
Oh, right at the corner then. Right at the corner.
Right in the corner.
Yeah, right there. I was looking at more of the French portion, because well, at least when I was living in France, I was fluent in French. I can't say the same anymore, but you tend to lose these things. They say if you don't use it, you lose it, and there's something very, very true about that. Anyway, I was quite fluent in French when I was living in France, but then I've lost that over the years. But anyway, I was looking at the schools more in the French speaking portion, just because that would make the most sense for me. But okay. That's fascinating. So, okay, so you've got your PhD, that you're going to school. You decided at some point that you wanted to go on for it. And then how did you end up in astrophysics? I mean, there's a bunch of different areas of physics that you can go into. Yeah. I mean, I'm guessing did that stem from childhood as well? I mean, you're talking really about like this, no? Okay.
Not really. I mean, I would say almost randomly. Maybe not that random. I mean, I wanted to go into high energy physics, so particle physics or quantum field theory, that kind of, that's just theoretical, that's humanly possible, practical, within the limits of my university. So one thing I realized when I had to do my master's degree is that you're no longer the one to pick your own project where you want to go. You basically go to a bunch of potential advisors, and they'll say, well, I have this project that you can do. I have this project. And so eventually I ended up with this a German professor in Denmark who wanted to do something with nuclear astrophysics. So essentially nuclear reactions pertaining to reactions in stars or in astrophysical scenarios. So that was my master's thesis, and then he essentially put me in touch with another nuclear astrophysics guy in Switzerland. So I went there, and then I started getting more into simulations. So I ended up doing like X-ray bursts, which are like explosive hydrogen burning on the surface of neutron stars. So I built simulations of that.
Really interesting. Yeah. So with your master's research, then did you actually study nuclear fusion at all? You said you were doing.
No. It was essentially beta decay and proton gamma reactions on proton-rich nuclei.
I see. Okay. Interesting. I think it's also funny that you said that you wanted to study quantum field theory. Like that's what you wanted to that's what you wanted to go into was high energy theory.
Yeah.
And I think that a lot of theorists want to end up in that area, but it is so difficult. And I can speak to this firsthand because I actually started my PhD out attempting to go into high energy theory.
Yeah.
So I've always been drawn to theoretical physics. I just like the mathematical component of it more than the experimental.
Yeah.
And when I was doing nuclear fusion, it was again theory, but that didn't work out. Then I ended up coming back to the United States, and I just kind of went back to my alma mater that I got my master's degree from. And I have a professor at my university who I've taken a number of theoretical physics courses with, like general relativity, quantum field theory, and he's just absolutely phenomenal. I like, again, theoretical physics more. I'm kind of drawn to it. So I was going to do work with him, and he's a field theorist. I tried to do this work for about a year and a half or so, and this meant that I had to actually like self-teach me, or excuse me, learn on my own, I should say, a number of aspects of quantum field theory that I actually didn't learn in the class. So I had to independently take quantum field theory, and then I had to try to do research, and the research was on like higher level loop calculations. So it was incredibly intense using Mathematica, building programs, things of that nature. I also didn't have any funding. I just had like minimal TA funding. I didn't have any sort of research assistantship. So I was trying to do this highly technical research and then balance this with also working a job too while you're in graduate school, and balance other life responsibilities. And it was a bit of a nightmare. And let's just say it didn't work out, unfortunately.
Yeah, what I observed or noticed was that there seems to be like two different kinds of students. That's like, if you're like idealistic, you tend to go towards the subatomic stuff, you know, particle field theory, etc., string theory, maybe even. But if you're more practical, which I definitely wasn't, then you will go with solid state and atomic physics, because that's also where like the careers and the money is. I remember we used to have the Friday seminars approximately at the same time for the nuclear astro group as the solid state physics guys, and we got these like tin can cookies with they hauled the institutional coffee maker down to the lecture hall, whereas the solid state group almost always had their food catered in with waitresses saying, you know, but that's sort of like illustrative of me not really thinking through the entire thing in terms of subsequent work, in terms of a career, etc.
You know, that's really interesting that you said you kind of made the connection that you had the solid state people, or let's say material science, who were more pragmatic, and they realized that this is where the money's at. And then you had the people in theoretical physics, like high energy, maybe astro, where they were more idealists, and they're like, well, I want to do this anyway, and I don't care basically if I make any money doing it.
I don't even think it's something like that. I don't even think it's something like I don't care. It's more like I haven't even thought about it.
I haven't even thought about it. Okay.
Yeah, right. You're just kind of like assuming, right? You don't think
yeah.
You don't think in terms of like real life practical matters. I don't know if I'm projecting too much here, but that was essentially my attitude.
No, I can appreciate that, and you know, now that you've said that, I'm definitely more of an idealistic person, and I'm happy to admit that. However, I like to try to stay as grounded as possible in reality, is what I tell people. And I think that has been, that attitude, that more towards grounding, is not something that I have done of like my own volition. It was kind of like forced upon me. It's like, if you want to exist in today's society, you need to understand that, you know, that how it operates, I suppose, and that there's not a whole lot of money in this particular space, and that it's just because society doesn't value it as much as you would like them to. So, and that's just how it is, unfortunately, but whatever.
I mean, I think a nice side effect of being sort of on the more idealistic side of things in that regard is that one tends not to develop a fascination for bling, or sort of like the nice consumer items in life. that's not why you do it, so you can easily do without them, right?
Yes.
That was definitely but when I was doing that, I was like, yeah, just give me a computer and access to the archive or something, and then I'll be happy for the next 40, 50 years. Right?
Yeah, absolutely. Yeah, I think that you realize at some point, if you are more of an idealist and you operate in the space where you're not getting access to a lot of resources, but you don't really, you kind of realize that you don't need these things to be happy, right? So I'm curious, now that you bring that up, when did your minimalist kind of life philosophy, the early retirement, all of that start to develop for you? Is that something that developed, you think, like earlier, like undergraduate, maybe it was before undergraduate? And kind of when did it really become implemented in your life? You're like, at this point, I've developed this philosophy. Maybe you even wrote it down, or maybe you're just collecting thoughts over the years, but it's like, I really want to live my life like this.
Well, it's definitely more inductive in that sense. But I mean, I've always been somewhat of a tightwad in the sense that I had a very specific value to my money, but it was also, I also tended to spend it on computer hardware. As opposed to, say, like a beer or taxi drives and nights in town. So I would be, my personal finance, my personal understanding of money essentially was that money was something you saved up slowly in order to buy something like a gadget or a widget or something. And it kind of comes back to this kind of like a gearhead, gadget consumer kind of thinking. So that's what I did basically until I started in grad school. Buying a new hard drive, upgrading the computer, getting a bigger monitor. The last huge thing I bought was a 23-inch CRT monitor, back when the standard monitor size was maybe like 17 inches or something.
Okay.
That thing cost like more than 2,000 Swiss francs. Just for a monitor.
Expensive. Yeah, just for a computer monitor.
Expensive, right?
Yeah.
But then so I was essentially living, decided to not spend too much money on my living quarters. So I was I chose to stay living in a dorm when I moved to Switzerland, rather than get an apartment and a car now that I could afford it technically. And that room was hooked up to like a T1, I think, LAN connection, so really good internet speed. So I was essentially spending the evenings either working or surfing, browsing the internet. That was back in 2000. And at one point I accidentally, I have no idea how I ended up there. I have some idea, but I ended up on a website, sort of like designed in the 1990s style, about anti-consumerism. And that essentially blew my mind. I had never really thought about where the resources of all my computers and cameras and the things I was buying, where they came from, and that they might be limited. And I had never thought about what happened to things after I threw them out, where they would go in a landfill, or the pollution they might cause, where the minerals came from, like coltan and stuff like that, mining in the Congo, all these kind of like the wider net, other than just reading like hardware reviews of awesome, like new toys. So because of that, I actually became really concerned about where the world was going, and that we might not end up in that kind of, like Star Trek future I had envisioned that we were going towards. I mean, you said you were working, you would prefer to work in fusion, right?
Yes.
And I kind of took that also. I kind of took that as grand. Okay, so we'll get fusion, and then we'll put that in spaceships, and we'll go to like the outer planets within like 100 years or something. And that's essentially what I saw myself as a physicist helping to do my little part to move that forward. But then I kind of became aware of all these other problems, and so that was kind of like the one thing. I gotta stop. Like I gotta like curb my enthusiasm in terms of like my consumption pattern here, because this can probably not go on. So I essentially did what like the kids these days call like a buy nothing year. I stopped buying everything other than food. And of course, when you do that, you start saving up a lot of money. Now, as a physicist or as a scientist, I had this kind of like arrogant attitude towards anything financial or money or business. As in, like, this is, I'm kind of ashamed to admit this to me, but my attitude back then was that all this stuff is sort of like beneath my, like my brain space, and I don't have to care about that stuff. Kind of goes back to this being like more of an ideologically driven, or driven by interest and driven by practical realities of actually working in a career of a scientist. So I started reading into that as well. So we have on the one side, we have sort of like the anti-consumerism, and the other side, we have the personal finance education, which during my schooling was almost completely absent. They did not teach us any of that stuff. Like, how does it
Are you talking about like finance?
Yeah, basically finance. I mean, I think the most advanced was sort of writing on a budget or something, or balancing a checkbook. It was kind of like at that level,
No, it's the same. It's the same here in the United States. It's just abysmal. It's awful. Yeah. I had like a semester, I think, in high school on personal economics, they call it.
Yeah.
And I learned about what the stock market is and how to balance a checkbook. That's really what I took away from that class.
That's way
and what a savings account is. And it's just terrible. It's not enough.
It's
not even close.
Way beyond. I mean, the sort of the closest we got to that is 1 hour of math class. Maybe it was 2 hours. Maybe it was a combined hour. They walk us down to the nearest bank, and we got a Coca-Cola or something. And then we had this like young bank assistant with an overhead projector talking about what kind of, we could get a car loan, or we could get like a house loan, or this required a down payment. But you could get a loan for that too. Basically, a sales presentation. And that would essentially be combined with the sort of like the career advice we had gotten throughout the entire system, which was, well, what are you interested in? Oh, I'm interested in physics. Oh, you should just go study that. So no concern of like what are like the placement ratios. What can you actually expect to have a job as a physicist when you get out, or will you end up in tech support or teaching high school or something like that? Or like retraining, or what kind of income levels we'll get. So no consideration based on that. So it was all about what is your passion, what are your interests. Once we were like almost done, they had these career days, which was actually more like half a day. So it's not like in the US where there's typically like internships that gets you in contact with an actual job at some point. There was nothing like that. And there we would, again, here's a brochure about how to sign up for like the unemployment insurance and joining a union, which is a big thing over there. And something about, well, you should probably start a pension savings plan before you're 30, but, basically blank slate, right? But as a physicist, you're pretty good at developing understanding based on fundamentals. So after realizing that insofar I bought a house with a mortgage, I would end up paying twice the price of the actual house I was buying in interest, then my inner type was saying like, no, we're not going to do this, right?
Yeah.
that just seems crazy, right? And then so the idea there became, well, I'm going to save up so I can buy my first house in cash. And then that combined with the anti-consumerism, where I was suddenly not spending money, it just became okay, instead of like saving up for a 23-inch CRT monitor, the 24-inch, which would probably be coming out next year. So the world hadn't moved to like LED screens, LCD screens back then. So there was still these, like big boxes on top of desks. I figured, okay, this is just me saving for something that's something bigger, right? But a lot bigger, but still the same principle. So everything went into a savings account, and essentially by the end of my PhD, when I graduated, I'd saved $90,000 of my student stipend. So, but there was no real sort of like I would say coherent philosophy at that point yet. It was just sort of like, okay, now I have some experience in basically not spending money and figuring out that I can actually live quite well live a decent life as a sort of like doing research and sort of like
Yeah.
self-actualizing as an intellectual.
You know what's really interesting too, Jacob, is that as a graduate student, you don't make a whole lot of money,
Right,
and but the realization that you don't need a lot of stuff to make you happy,
right,
because
exactly.
in capitalistic societies they sell you on stuff. I mean, that you always need to be consuming, and that this is kind of like your responsibility to society is to consume stuff. You go
Mhm.
to work and then you bring home money, and then with that money you're supposed to buy things with it, and then
Right.
that's just how it works. But yeah, it's just this cycle, and there's so many people that are stuck on this or convinced that this is just normal. And as you know, I mean, there's no reason why it should be considered normal. It's
Mhm.
just that it works really, really well for people that want to sell you stuff.
Exactly. Yeah. So in a sense, I mean, I also had this kind of like, okay, I mean, the sort of like the early seeds of that kind of thinking were kind of so like, I didn't want to be some like ant in the anthill that was just being mined for my productivity, so I could sort of be happy with buying stuff. I sort of began to see uh, the tragedy in that,
It is
and
a
I also,
tragedy. Yeah,
yeah, and also kind
it
of.
is a tragedy.
Mhm. And I also kind of had bought enough stuff. I had been in that cycle for long enough. I've been working since I was like 12 years old, like weekend jobs and stuff like that. And all my money went that way. And so at that time, I already had like 12 years of experience as sort of like a consumer of stuff. And I was beginning to realize that it was almost like a drug addiction in a sense. You save up some stuff and then you buy this shiny new toy, right? And that gives you this kind of dopamine injection that lasts somewhat briefly, right? And then you need to buy something else, and it's not exciting anymore. You research a new SLR camera, for example, and you learn all about photography, and then you run around taking pictures for 2 months, and then that gets boring. Then you buy a telescope or something for the next savings, and so at least I did. I mean, that's kind of how it ended up, and the sort of like the treadmill I was on, also called the Hedonic Treadmill. And I was
Oh
beginning
yeah.
to realize that there should be more to life than this. This does not make sense that I had to that this is the only thing that is essentially there. And also like what you said with grad school. I mean, there's more to life than just like working and getting paid and then buying stuff. In grad school, you have access to like very interesting people. You're doing very interesting work, so you can sort of like self-actualize in different ways than just buying fancy stuff or upgrading all the time.
Yeah, and I think that you talk about self-actualize and kind of figuring out what it is that fills you, makes you happy, so that way, like at the end of the day, you can feel satisfied. I think that creating really, really fills people with kind of that emptiness that buying things always seems to create. So you're talking about the dopamine hit. You get stuck on this hedonic treadmill. You buy something and then you lose interest in it.
Mm-hmm.
And that if you figure out how to create something that fills you, that can always satisfy you. And what I mean by that is that you don't have like these highs that somehow need to be supplemented all the time with something else. For example, like I love to write, similar to you,
Right.
and it's just something that I do. It's how I fill my time, and I get into these flow states, and it's very satisfying. And I'm just creating. I'm just sitting there. I'm creating. It's my computer screen and a keyboard, and it doesn't cost me any money. I mean, it costs time, but it's how I like spending my time.
Yeah.
So if you can find ways to enter these flow states where you are creating and not consuming goods, that you're then like on a different type of, I don't want to call it hedonic treadmill, but just a different way of filling your time.
Yeah, I mean it's a multi-dimensional space, and essentially consumers are locked into one single dimension where everything is measured in money, often kind of forgetting that there are other ways than buying things and unwrapping them and then organizing them and putting them away or throwing them away. What was I going to say? So another thing with respect to the anti-consumerism, I was also beginning to look. So it's not just driven by sort of like resources and pollution. There was also some sense of limits to it. And you probably heard of the ecological footprint and how we are like consuming more than one planet.
Oh yeah, absolutely. I'm intimately familiar with the field of biophysical economics, which
Okay.
is kind of like for those unfamiliar, it's essentially a newer philosophy of economics where you're including the planet and like environmental resources into the mix of things, where the human economic system is no longer separate from the planetary, where you're trying to merge all of these things together, which makes perfect sense because if you think about traditional economics that preaches growth forever, which is completely at ends with the laws of physics, since we live in a finite planet. I mean, you can't have unlimited growth on a finite sphere. It just doesn't make any sense.
Yeah. I mean, normal sort of 19th century economics are essentially presuming infinite boundary conditions on the resource side and the sink side, the pollution side. Whereas, finite planet.
Yeah.
So one calculation I did very, very early on was some back of the envelope calculation using the planetary or the ecological footprint and the world GDP to see, well, what would be the limit if everybody lived in a particular way? Could we actually like make a sustainable world? What is like the per person consumption in that case in raw dollars? And the result back then was like $6,000 per person per year. So if you spend more than that, you're essentially removing resources from some other human, either in the present or in the future at some point. So the current number is something like 6,700 per person per year. So my goal was to see essentially, can I live like that? And having just like moved to a new country, arriving with just a couple of suitcases, it was kind of easy for me. It's a lot harder if one is already established in a huge house, like with family and 10 cars, etc. But I practically started with a blank slate, and then I tried to keep under the limit. So for me, it was not very hard because it was that limit was very much similar to what I was already getting in my stipend as an undergraduate. So I already had experience living at that level. All I had to do was to learn new skills and in terms of how to spend my resources. I don't want to say just money, but spend my resources, leverage by learning other skills that I haven't learned in school to stretch those dollars more than just on a one-to-one basis. Like instead of like getting $1 of good out of $1 spent, how to get $2 so you can live a better life. So that was sort of like my initial experiment. But in terms of philosophy, which I think was sort of like the question asked like 20 minutes ago or half an hour ago, it was not really a coherent philosophy at that point. It was just something I did, but I did not have sort of like an intellectual framework for what I was actually doing. Yeah, it was more like intuitive. This is just how I lived.
Yeah. But you were driven by this idea of essentially anti-consumerism.
Yeah.
And then at some point you became concerned for the environment. And then you were like, okay, well, let's look at the carrying capacity of the earth. And as far as the resource limits, you realize that, hey, we can't have infinite growth with finite boundary conditions. It's not compatible. It doesn't make any sense. So what level do I really actually need to live in order to be sustainable with the planet? Okay. And you realize that it's actually quite low. I mean, trying to live for what, $6,000-$7,000 a year, you said?
Yeah.
$6,000-$7,000 a year on, in the United States, that's going to be challenging, I think, for a lot of people. I think a lot of people would find that challenging.
Well, I mean, I don't want to get into like purchases. Whenever you get a specific amount, then lots of people start gamifying the metric, right? Like, okay, I have 7,000. I'm just gonna like move to Thailand where that money goes a lot further.
Yeah.
Right? So that's cheating. That does not count. Right? So that's purchasing power parity to keep in mind. But in general, it gives sort of like the ballpark of what one should be doing. I mean, there's obviously also depends on whether you're spending your $7,000 allotment on like filling your swimming pool with crude oil and setting it on fire, right? That would be like pretty bad. Or whether you're buying sort of like your neighbor's vegetable garden. That would be a pretty good way of spending the money. But overall, I mean, the money flows elsewhere to people spending it. So it's you can't really sort of say, yeah, well, I'm spending it on green stuff.
Yeah.
Because you can be sure that the people you're paying, that money quickly goes out and gets spent in sort of like the standard way. So for me, the money level was sort of my target, to try very hard not to exceed that. The difficulty in doing that sort of again goes back to the way our generation was raised, and the current generation is raised, in that somewhere for my part back in the 80s and 90s, it was decided that, well, young people would be better off just learning how to sit in front of a computer on their ass, like for 16 hours a day typing on a keyboard, than learning practical skills like woodworking or how to cook dinner or how to like fix things around the house, how to repair stuff. They used to teach all this in school, and if they didn't, then the parents certainly would teach them, right? But in the past 2 generations, both parents have been off to work, so they didn't have time to teach anything. And the school was focused on this kind of like comparative advantage kind of thinking, in the sense that, well, if we teach someone how to program a computer, right, and they can earn $40 an hour, then that's a lot better than teaching them how to like fix a flat tire on their bicycle, because that's maybe only worth $10 an hour or something like that. So my sort of like my initial spare time, I would almost say, like, ever since I started thinking in these patterns, so for the past 20 years, I've always sort of been in the process of trying to learn some new practical skill, where I don't have to go pay a specialist to like fix a flat tire on a bicycle, when I can do it for like 25 cents and 10 minutes of time myself. So that kind of comes back to the thing I described in my book, and this, where it started becoming a philosophy of what I call the Renaissance man, or the Renaissance person, in which before industrialization, a well-developed human was sort of like development. I think as a mature human should be able to be skilled in multiple things at the same time, not just one thing. I mean, everything. Yeah. Society.
They were more of a generalist than a specialist. Yeah, they were more of a generalist rather than a specialist. And even in more, let's say, less developed societies, South America, New Guinea, wherever you want to go, where you have these tribes that live off the land, it is shocking how many skills these people need in order. I think for the average person here living in the United States or a developed country, Denmark, any other of the developed European countries as well, if they were to go and see how these people live, they would be blown away by how many skills that these people know. Yeah. And it's interesting is for the men in these particular tribes, from what I have seen from like documentaries and things like that, it's like you can't even have a family, like you can't have a wife and you can't have children until you learn all of these things. And it's like a huge skill set, because you need to know how to live off of the land and be able to not only support yourself, but then be able to support a family. So in order to do that, when you're out in the forest or wherever it is you may find yourself, you need to have an incredibly diverse skill set in order to survive.
Yeah, I think in one of the sections in my book, I say something like something according to you're educated in proportion to how well you can manipulate your environment. And by that metric, we are like woefully uneducated in the modern world. We understand essentially an extremely narrow, like almost like a delta function of skills that we can earn money from. And then we use that money to compensate for all our other inadequacies and everything else with regards to our environment. We basically only know how to pay for something or call someone and complain about it until it gets fixed, and hand over either some dollars or a credit card number. But that's about it. We are essentially not educated anymore. The education per se, I would say, exists at a higher level. It no longer exists at the individual level with as far as humans are concerned. So, I mean, what I mean by that is it's kind of like, so my best metaphor is essentially like an anthill. So the individual ant probably does not understand what's going on, but different kinds of ants together are capable of running the anthill, and it's the same thing with humans. That system, however, is not the best for an individual ant. It's essentially dispensable, and I think the same thing is the case with modern society. I mean, you can hire and fire people as you will. They're basically just components in a system. So that was my depressing talk for the day.
No, I think it's a fairly accurate analogy of today's world, though. And it's interesting. You're talking about people not learning the skills. I think, though, that at least maybe this may just be a sampling bias, because I am surrounded by a lot of people who embrace kind of the more minimalistic lifestyle and just trying to figure out how to detach themselves from the restrictions that being in financial debt can cause someone. So, but they use YouTube a lot, and I think that YouTube is a great resource. It also is full of a lot of nonsense too. But if you know how to discern like the good from the bad, if you're a responsible consumer of information, that you can find an incredible amount of information on YouTube when it comes to how to fix anything.
Right.
You've got something wrong with your car, like a 1986 Civic, and it's got this particular problem. You can find somebody on YouTube who probably has already solved that problem, and they made a video about it. It's absolutely remarkable what you can find on YouTube these days when it comes to just solving problems like around the house, or if you want to learn how to make a clock, you want to learn how to make a guitar, you want to learn how to fix your water heater, whatever it is, you can find a video on YouTube from hopefully a credible individual, and they will teach you how to do it as long as you put in the time and the effort.
I mean, YouTube has definitely like fulfilled some of like the original promises of mass media in terms of or media in general, in terms of creating a more informed public. I mean, it's not all co-opted by propaganda. I mean,
no. Yeah, there's definitely plenty of good.
They said the same thing about TV, right? Wow, now we have like a screen in the room of every house. Imagine all the things we could teach people with a device like that. And of course, it's like kind of like the internet turned into like cats and porn, right? The TV turned into, I mean, it's but it could have been different. It just isn't, right? Because of, I don't know if it's human nature, whether it's human culture or what it is. I mean, the technological potential is there, right? But the I don't know if it's sort of like the physiological or the psychological or whatever cultural potential is apparently not yet there, or not there yet.
Yeah. So going back to your philosophy.
Yeah.
So I've read your book. It's fantastic. And there's an intellectual portion of it that you talk about, that the Renaissance man is, and you actually use the word critical thinker in there, that a Renaissance man must embrace critical thinking and be open to being like a lifelong learner, things of that nature. So I'm just really curious as to what critical thinking means to you, as far as like your philosophy goes.
Yeah, I actually kind of forget that I wrote that in that way. What I think I meant is probably more what falls under like intellectual capital or intellectual development, in that there's a general tendency in society to stop thinking, or maybe not even begin thinking. Let me rephrase that. There's a general tendency to stop picking up a book at the time one leaves the educational system. As something like 95% of people read 95% of the book. It's a phenomenal power law in the sense of the skew, the Pareto distribution on people who actually study or read books.
Yeah.
It's
a small percentage, like you said. I mean, I think a lot of people, like even college educated, as soon as they graduate, they don't pick up another book. They just go off into their career, and then
just kind of stops, right? So people they specialize to get a job, and then they just stop evolving, essentially. and not just sort of like skill based or sort of like like intellectually in the sense of like typically an intellectual will be someone who is interested in like philosophy and psychology and biology and all kinds of different areas, but they also kind of stop. There's not much introspection going on anymore, so there's that too. By critical thinking, I think my best definition of that is some kind of like metacognition, thinking about thinking. So if anyone can think, or anyone can at least think they think, but the habit of thinking about what one is thinking about, that is somewhat rarer. And if that habit does not exist, then the thinking can be used for somewhat destructive purposes. I mean, you don't. I don't think anyone will admit to the fact that they're not thinking critically. You know, right?
People definitely will not admit to that.
Yeah, I mean, it's one of those labels. Yeah, of course it's critical thinking, you know, because I really thought about it, right? You're right.
Yeah. So thinking about thinking, yeah, I mean, that is, I think, the essence of critical thinking. Is that you just need to engage your metacognition, those higher order thinking skills, and just like start asking yourself, you know, why is it that I believe what I believe? How am I putting my thoughts together? How do I know what is true, what is false, etc.?
Yeah, but this kind of exists on different levels as well, which is, I think, I mean, it seems like incredibly arrogant, and I hate doing it, but I like to sort things in by like levels. Or stages, because I mean there's a tendency to see, okay, there's either critical thinking or there isn't, right? Whereas I think it's better to see, well, there's a like critical thinking at some stage, and then there's like the next stage and the next stage and the next stage and so on. And so I like to try to identify various levels of how do people think about things, and this to me at least has made it a lot easier to navigate other people.
No, absolutely. Yeah, that makes perfect sense too, thinking about it on a spectrum. You know, so if you want to, like, I don't know if you want to call the category, or if you want to call it like critical thinking or like metacognition or whatever, and then it comes in a spectrum. People engage in higher order thinking, and you know, in a spectrum, right? So you have on one extreme the people that don't do it at all, and they kind of just believe whatever, and they just kind of go through the days, and whatever happens. And then I guess on the other end of the spectrum, you would have like the extreme, you'd have like the Spock types, right? The extreme logician and someone of that nature.
Yeah, I mean, I mean, there's like multiple different psychologists that like worked on this. But I mean, like my favorite, like as a physicist or like as a computationalist, my favorite one was probably like Gregory Bateson, which had like a very simple model that thinking is essentially like a feedback process. So it's a regulator, right? You have an input, you have an output, and then at the zero level, you have no regulator. So that's essentially just like an electrical wire, right? If you turn it on here, it's on here, right?
Yeah.
Then you can have like a feedback loop going back from the output that regulates the input somehow. So if that was heat, you have like a thermoregulator, like a radiator, like a heating system. So that's sort of like your general construction model of how it would go to higher orders. So the next level beyond that, then you would have a feedback on the feedback itself. You would have a way of changing the feedback mechanism.
Yeah, that's really interesting. So you're talking about like loops, right? Like loops within.
Yeah, like a loop.
So I'm thinking like quantum field theory now. Like you're talking about higher orders and perturbation.
Exactly. Yeah. So this, in a sense, can go all the way up and
ad infinitum, right? And then, but like each higher order process, you may get a little bit better, but you lose. It's vanishing returns essentially. But
no. I would say actually the returns go up incredibly fast in terms of how powerful the thinking gets.
Oh, you think so? You don't think it's like an exponential decay, like in quantum perturbation theory?
It's not like in QFT where you have some kind of like 1/n to some power factor.
Yeah. Okay.
That just kills everything.
Yeah, it just kills everything. But
I think it's more something like it's at least, you know, like n squared or n cubed as you go up by power. So no, I don't want to say anything bad about like your regular like house plant or something. But a house plant is a good example of a naive example of something with no feedback. So it just is, it grows, it doesn't do anything. So now all the biologists will tell me that it responds to temperature and humidity and so on and so forth. But if I talk to it, it doesn't talk back, it doesn't react to that, whereas like a dog would do that. So a dog has a somewhat more complicated feedback system. Right?
Oh yeah, absolutely.
Yeah.
I mean, I wouldn't say that a plant has no feedback system.
Yeah, no, exactly.
Because yeah, I mean, they respond. They clearly respond to sunlight, right? I mean, the positions of the leaves, but that is going to be slower and not nearly as complex as a feedback system of like your pet dog or cat.
In particular, it's going to be very predictable, right? You can practically draw a curve where you like test it along the curve, right? It's probably going to be some kind of linear feedback.
Okay, so I understand your analogy now. Yeah, that makes sense to me. That you're talking about. Well, I mean, I guess like greater than exponential growth. Then, if you're talking about n cubed or something of that nature.
Yeah, I mean, I'm just talking about a simple functional.
Yeah. Okay.
So when and your function becomes is in some sense recursive, right? So in terms of the Bateson levels, so they go up in terms of, maybe it's better to think of it as sort of like your generic hardware. But what kind of circuit can you make with a wire? You can connect other things, but it can't really do much with the wire itself, except maybe it responds a little bit to heat, depending on, the resistance goes, I forget, is it up or down? It goes up, right? But that's about it in terms of like external feedback. Whereas if you have like a diode or a transistor, that can do a lot more, and a microchip can do even more because that's several transistors regulating each other, right? So in terms of what I mean about so the other thing is it's kind of like when you talk about intelligence. What is we can measure intelligence of humans based on a test, but like how intelligent is a horse or a dog? How do you do that, right? How intelligent is a rock? Does a rock have intelligence, right? Well, it knows how to fall down when you drop it, technically. Maybe I'm like disturbing your sense of gravitational theory here, right? But how do you know that theory is correct? Like that's just something we think. And also like what is an IQ of say like 400? What does that even mean, right?
Yeah, I wouldn't even know.
Yeah, nobody. I mean, it's very hard to know, but it's also easy to understand it in the abstract. In the sense that if in terms of feedback loops, that the power they go to, that you can kind of understand that can go technically all the way up.
Yeah, and
I guess feedbacks to the cube, feedback, quadruple, etc. But in terms of like what can humans actually do in that regard, it becomes a lot narrower. I think I have to be careful about saying most humans. Some would just react to a statement and then repeat with a predictive response, right? Others would think about it. Others would think about what they're thinking about and whether the context matters, etc. Maybe it's a little bit like juggling, right? So apparently, I can't juggle with anything. As far as I understand, someone like me could learn how to juggle 3 balls in about an hour. Juggling 4 balls, though, is something that you would spend like days on, if not weeks. And I might be completely wrong here, but the point is that it's definitely a lot more than an hour. It's not 2 hours to add an extra ball. Whereas 5 balls, now you're talking like maybe like months, if not years. 6 balls, then you're like top of the line. So the difficulty goes up really, really fast. So it's almost like, if sort of like the potential complexity of the system is like n to the n. Like n to the n, a mathematician would easily understand what that means. That's something you can operate on. You have some kind of shorthand, algebraic notation that describes n to the n, but trying to understand that actual number. If n is 1, then it's easy, right? Concentrating on the amount of manipulating figure for 2 is also easy because that's 4. You can picture 4 things in your head at the same time and sort of move them around. The average human can do about 7 or 8. I think the range is something between like for, you would say like for low intelligence, something like 4 or 5, for high, it's maybe 8 or 9, but it's not much beyond that range. Whereas if n is 3, then you're talking about 27. So in that sort of like simple physical model of what the human can process, then the n for humans is slightly over 2, right? With tiny variations in there. Does that make sense?
Yeah, absolutely.
Like,
Yeah, no,
yeah.
I get it. Yeah, I understand what you're talking about. The complexity goes up very quickly.
Yeah. So in terms of like the Renaissance, man, the thing is there that in general we just like operate with sort of like the idea that there are currently 2 stages to like human development, and that is like you have child on one side and then you have adult on the other side. So once you're like 18 or 21, then you become an adult, and then it just stops there, and you don't just do your thing until you're retired. And I am trying very hard to resist that. I think that like you can keep growing if you actually want to, in that regard.
No, I think it's an absolute tragedy that people don't keep developing, and there's just so many interesting things out there, and I mean, look at the statistics. I mean, like we were talking about earlier, that people just kind of put down their books as soon as they graduate college. And I'm not saying that people don't watch documentaries. I actually think documentaries are a great way beyond just reading to get information as well. And I think it's easier. You may not get as much information out of it as if you're reading the book, particularly depending upon like how you read a book. Like if you go through a book and you like highlight it and you make tabs and things of that nature, you're going to get more out of the book than if you were to just read it. And I'm talking about like nonfiction. I'm not talking about fiction novels, but like the nonfiction, the books that will help you to develop your knowledge base. But anyway, I mean, yeah, people just don't do it. They don't regularly engage in watching documentaries, or they don't engage in reading nonfiction. A lot of people will prefer to watch movies, fiction, maybe based on some nonfiction events, but mostly fiction oriented, or they read fiction novels. And that isn't going to help you to really increase your knowledge base, at least not to the same degree that you would if you were to watch documentaries and read nonfiction. Of course, movies have facts embedded into them, oftentimes, depending on what type of movie you're watching. But yeah, it's just a bit of a shame. And I'm a huge proponent of lifelong learning, and I know you are as well. And that's kind of you talked about that a lot in your book, that the Renaissance man is a lifelong learner. And I could not agree more with that.
Yeah, I mean, in some sense, I mean, that's just my preference in that sense. I mean, the alternative being like lifelong consumption, right, where you don't have to learn anything. So what I'm presenting is more of, I would say, an alternative of another thing one could do.
Yeah,
and lifelong learning, that's sort of like the added side effect of being able to live like a rich life with less money if you learn practical things, I would say.
Yeah.
But I don't think it's realistic to sort of like expect that we all become like a learning society in that regard. It's sort of like the question of where do you set the dial, where it should be. So right now it's like really all the way over where learning is almost not a thing outside of. I mean, we as a society, we kind of brag about like our college graduation rate, right? Or how many people go to high school, how many people go to college. So these are metrics, but there's like nothing measuring anything after that. I mean, that's weird, right? I think that's weird.
Yep, I agree with you. I agree with you. I don't understand it.
Yeah.
And similar to we were talking about earlier with the financial aspect, and how that is essentially non-existent in the public education system. Critical thinking is, from my observation, non-existent in the public education system. I don't know how it was for you in Denmark, but I know here in the United States, essentially it was just fact memorization and then regurgitation. It wasn't, how do you put your thoughts together? We didn't learn anything. Like for me, critical thinking isn't just about like thinking about thinking, but like then like learning the tools as well. So for example, what I really talk a lot about with intelligent speculation is informal logic, and how do you essentially structure your thoughts, arguments, etc., from first order principles or like axioms, things of that nature. And I mean, I didn't learn anything about philosophy, nothing in my public education. And I was even shocked as a scientist that I wasn't required to take any sort of formal classes in philosophy. I mean, I took a lot of mathematics, and mathematics, I think you could argue, you learn logical arguments, things of that nature, through proofs and things of that nature. But I was just kind of shocked that even in my university education as a scientist, that I wasn't required to take like any philosophy of science courses or any other philosophy courses.
Yeah, I mean, it's very easy to sort of like get into some kind of like grand. I mean, there's not an emergent conspiracy about all this, that you can't show the fish the water they're swimming in, because if they did, they would break the system. I don't know. This is almost like Matrix the movie kind of thinking.
Yeah, I can appreciate that though.
Maybe people would become very unhappy if they started questioning everything. I mean, certainly happened to me in the beginning. Like, what are you saying? Like, Star Trek isn't true, right? Or future Star Trek isn't true. So there's this joke someone told on my forum a couple of months ago. So I'm probably retelling it pretty badly, but I think it's sort of very illustrative of the sort of like perspectives of different fields. So the question. So you have a scientist, a physicist, and you have an engineer and a mathematician. And the question is, so you have a red ball, and you're supposed to add. Bad tell of jokes here.
Yeah, no worries. I think I've actually heard this one.
The red ball, you drop it. How high does it bounce?
Okay.
So you ask a physicist, an engineer, and a mathematician like that question, and I've certainly recognized that in myself as a physicist, and it definitely nails it. So the physicist would either do some like back of the envelope calculation and get the answer right within like a margin of like 40-50% or something, or they would build a microscopic computational model based on first principles, going all the way back and simulate like the hydrodynamic shock and probably get the answer right pretty accurately, but it would take them like 3 years to get it or something like that. So that's the physicist. So the engineer, they would quickly look it up in the bouncing red ball table and get the answer right within 1%. So the mathematician would paint the ball blue and refer back to the blue ball theorem, which is already solved. Laugh. But I think the point is that those are three very different perspectives and approaches to how to deal with those questions. What the physicist is doing is essentially asking, why is it the way it is? And they're trying to reconstruct the entire understanding based on like the microscopic properties and the bouncing ball. So they're interested in knowing why it bounces. The engineer is interested in how it works, right? So they take essentially the fact that the ball bounces for granted, and they just don't want to know how a ball bounces, sort of like how high it bounces back. And
they want the most accurate answer. They just want to.
They also have the most accurate and the fastest answer, right? The simplest answer in some sense. And the mathematician is interested in the what. Right? What is this problem? Well, it's a bouncing ball problem. Can we like reduce it to a previously understood problem? And I've gotten into a lot of hot water arguing about these the practical sort of like just philosophical disagreements with it between engineers and scientists in those two terms. I mean, it's not such a thing that one is better than the other. They're definitely complementary, right? And it's also not like scientists are not interested at all in the hows or the whats, but the main focus is on this particular why, and then the how and the what is just sort of like something you bring in a little bit. The engineer is primarily focused on the how, and the why and the what is of secondary importance, and similarly with the mathematician. And I think that's also kind of like going back to the F.IR.E. philosophy as I developed it, is pretty explicative, clear that it was developed by a scientist. That was interested in the why. So it's just like from microscopic principles, like all the way.
I think it's very clear though that it's a physicist and not just any scientist, because of the first principle natures of your philosophy.
Right.
It is very, very first principles. And I mean, it just has a physicist flair to it. And if you told me going into it, if I didn't know that you were a physicist by trade, I probably could guess after reading the book
Yeah,
that you were a physicist, that a physicist wrote this book.
yeah,
And in my opinion, and I'm obviously biased here, but I think that there's something very, very powerful about that skill set that a physicist
right.
gets through its training, through
Yeah,
first principles
yeah.
thinking.
I'm also
Thinking
biased, but I agree.
yeah. I just think that it's incredibly powerful, and it has led to incredible advancements in human knowledge and the technologies that we have today. Some of the most profoundly impacted technologies are, of course, they're all areas of science, but there's some argument to be made that perhaps physicists, even physicists who went into other areas and are a bit of polymaths, but then they go in with this first principles thinking, and they kind of really change the game. And then all of a sudden, we're going down a new trajectory.
Yeah,
I
because
mean, even in modern times, I think that the most popular and impactful, I guess, technologist of our time is Elon Musk. Of course, there you can make arguments for other people too, but out of the Silicon Valley space, you have Musk, who is just disrupting all of these different industries. He's a huge popular icon, and he's a physicist by training.
yeah,
So yeah,
I
he's a
mean,
physicist.
if you like compared to practically any other like personal finance pro, program, it's I would say written by engineers or technologists in that sense, and it's more about how do we optimize the current system, not how do we build why is the current system the way it is, and let's completely reconstruct it. Instead, it's more like, okay, we have the system as it is. Which styles should I tune to like maximize my 401k, or if I dial it this
Yeah.
way? So that's the engineering approach. But with that, you can't change the behavior of a machine by like adjusting its sort of like.
No, yeah, by fine tuning it, and you still have
That.
the same machine. But if you can go in and say, well, do I need this machine? Can I make a better machine?
Yeah.
Then yeah, that's how you kind of really shift one's thinking and one's trajectory. Particularly if you can make a better model. Going back to like Elon Musk. Okay, Elon Musk with SpaceX, for example, he didn't say, I'm going to take the existing rockets and with what we have, and I'm going to just kind of fine tune the rockets that we already have. He went in and said, I'm going to create brand new rockets and I'm going to make them reusable. And that's that was completely game changing. I'm not saying that the rocketry is brand new. Some of it is, but what I should say is I'm not going to say that he didn't reuse some engineering, all right? Because obviously you're building upon decades of rocket science. But he went in and he kind of changed the game when it came to like saying the notion that I'm going to reuse rockets and I'm going to build better. I'm going to build different rockets with great engineering, and then I'm going to reuse them. So it was just completely. It was just a different way of thinking that he went into.
So like in terms of like Bateson, like in the feedback loops. And if we think of that as wiring, then the sort of the task of a physicist and the way they're sort of taught to operate is to find the structure of a given problem, which metaphorically would mean the wiring rather than tuning the wiring. And the thing that again, that relates to critical thinking in the sense that critical thinking is making sure that the wiring is correct, that the wiring, your structure of understanding actually matches reality. Because there's nothing more, I would say, obnoxious to a physicist than someone trying to argue a point about reality with the wrong structure. Right? Say they insist that the Earth is flat. Technically, it is round, but they have to essentially hammer that point in and find some way to argue that the Earth is flat because that is their core belief. That is the structure that must be adhered to. That makes sense. I mean, it's like kind of like the human body, right? It only works if the skeleton is put together in the correct way. If you put both arms on the left side, say it does not matter how well you tune your arm software if your arm is not positioned in the right correct hardware spot. Maybe my metaphor is like decaying here, but I think
No. Yeah, I mean, I understand. I understand the point that you're trying to make.
yeah.
Yeah, that the structure that you build the problem in is really, really important. And I think, building upon that idea, Jacob, solving problems in physics, maybe maybe this might be a better analogy, is that I oftentimes would be just infuriated going through training, like taking courses and things of that nature, because you can set up these problems, like you go to approach a problem and you kind of set up the structure, okay? And then within the structure you have the mathematics, and then you crank the mathematics and you get something out on the end. But if that initial model is wrong, or the structure, what you get out on the back end while you've got an answer, it's completely wrong. It doesn't reflect, it doesn't reflect reality. So garbage in, garbage out. I guess it speaks to the importance of making sure that the base model, or the structure, as you put it, is correct. And,
I mean, that's the difference between accuracy and precision, right? And you can also see it sort of like in the development of a physicist as sort of like they mature as they get older and more experienced. If you go to like an undergraduate class, the argument will typically be something, blah, yada, yada, yada. And this is given by insert huge equation. And then yada, 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 and the result is huge equation. So I would say at that level, you're mostly operating sort of like without the wisdom of experience. Yeah. So it's mostly technical, it's derivation. And if the derivation is there, well, then that's the answer. Whereas sort of like at the more mature level, it's more like, what is actually going on in this particular physical problem? What are the core concepts here? What is the important part, and what can you disregard? And that's where you get to sort of like the back of the envelope thing. But that takes like years of experience. I think mathematicians call it mathematical maturity, but they mean something else by it. I don't know what the physics term is, but there's like different learning levels in the same way that you can be like technically brilliant as a sort of like a young physicist wannabe, but that is not going to carry the whole thing all the way up.
Yeah, I know, looking at my own training, and in the beginning, it was mostly just kind of pushing equations around and learning like from examples, like doing a lot of examples, but not really understanding what was going on. And then over time, as you begin to study these same problems over and over and over again, you begin to really understand what's going on and you develop this this physical intuition. And right, I think, I think that's what you're probably going for, is you develop this physical intuition that only comes from years of intense study within physics. And you look at a problem, and then you kind of you have an idea of how it's supposed to be solved. You know, like why the charges or why the balls or whatever, you can kind of see how they're going to move, and then how you need to structure the problem, and then you work it out. But that, I mean, for me, I just remember struggling tremendously in the beginning to get that nailed down, which is why personally I struggled with like quantum mechanics so much, is because I couldn't physically intuit what was going on. It's a lot of linear algebra and partial differential equations and things of that nature, boundary value problems, but you just don't really understand. But eventually you develop a physical intuition for that as well. And I think that's a lesson, kind of visualizing what is going on, but you get more of a mathematical feel for how things work on the quantum level and how they should look and operate.
It's in my opinion, it's impossible, or it should not be allowed to try to jump ahead of that. The technical aspects. You see a lot of like popularized nonfiction books where it's just, well, let's just skip all the technical stuff because everybody hates that, and then jump straight to the conclusion. And then you have these kind of like popular books about string theory where people talk about membranes and whatever without really having the slightest clue of what they actually are technically. I think that's like a huge liability when knowledge is presented in that way. So like with the Bateson stuff, Bateson is not the only one. There are like multiple different ways of learning. The learning models in terms of stages. So Dreyfus is another one. It's probably my favorite. And then I even made one myself for the book, which is the one I'm most familiar with. So that's like a 6-level thing, where as sort of like a noob in a given subject, you start just by copying what you see. You see, and this could go for any field. So like let's
yeah, I know precisely what you're talking about. You talk about that with financial understanding and things of that nature. I think
yeah, it could be
like
financial. It could
yeah,
also be like
the back of your
martial
book.
arts or something, right?
Yeah.
So for instance, to take martial arts as an example, I don't think if you're learning karate, you can't jump straight to like thinking like a fighter. You have to do your punches first, and then do endless, like until you finally realize that all this was just training you to the idea of punch, but you don't necessarily just punch straight. You can also punch in other directions, right? But that sequence essentially goes from like copying, and once you can copy things, you can start comparing them. So that's level 2. Compiling, then you start making lists. But you have to sort of, that's sort of like the base knowledge. That's a lot of different factoids about the situation that you now have compiled, which is the same thing you talked about, like doing like momentum calculations on charged balls flying around and colliding and all that. So that's sort of like the ingredients for thinking. Now you're practiced in like all these different physical concepts, but it was really the concepts that mattered. A lot of beginners prefer like to have information presented in that way. You know, they just want, like a quick, simple plan with a few tips in, like just give me a list of talking points. And yeah, I'm probably going off on a tangent. Let me continue the sort of like the list here. So once you have your compiled list of factoids, you can start computing with them or calculating. So that's where you get to sort of like the undergraduate physicist level, where this equation is given by this complex expression. It's essentially the sort of like the end point of the textbook problem. So like the torture you're put through, like the first 4 years of training, where you have a closed-end problem, you have all the ingredients because you've covered them, you compared them, you compiled them. They're definitely in the chapter right before. If the problem is at the end of the chapter, right? You just have to sort of like compute something out of it. Whereas once you go to grad school, then you start then you go to the next level, which are like coordinating different areas of knowledge. But in order to coordinate different areas of knowledge, you have to have different areas. You can't just have one. So maybe the answer to your problem is now found in the second book you haven't read yet, right? Mm-hmm. And so that's sort of like where the research thing comes in. And now you're sort of already talking about a level of thinking that I would say only a minority of people have actually engaged thoroughly. And once you become habituated to that, then you can actually start creating new theories, because you can coordinate different problem sets, right? So that becomes your sort of like creative output, but that only happens after you've gone through the copying, comparing, compiling, computing, coordinating.
Yeah, you can't skip the gauntlet.
And just
if you want to call it that. You can't
just create some shit, right?
you can't skip any of those steps, and it takes intense work and effort and time in order to be able to do that.
It's a little bit like artwork, right? Where in order to actually make some art, you have to know which rules to break. You can't just throw paint on the wall and call it art. Even if normal people who don't know artists, I have no understanding of art. But these like when they do like a TV show or something just for fun, they have a professional painting, and on one side, and then they have like 6-year-old having thrown some paint on something, and then you have like the audience deciding which one of those is like the real art, and they can't tell. So some fields are like that, but other fields are not. And for that, the artist can tell, but the audience cannot. So you got to know which rules you can break first in order to actually break them properly. So
no, absolutely. And like we were just talking about, that only really comes with a lot of experience and intense effort to where you can actually get to that point where you're like, okay, I kind of understand everything, and now I'm going to push the boundaries and see where I can go. And as somebody who is doing research now, it's taken me an incredible amount of time to be able to get to this point. Right. Years and years in effort. And I'm sure you can appreciate that. How long it took in your training before you were able to get to a point where you can start creating new science, new knowledge, essentially. But I'm just curious. So, like with the critical thinking, I feel a little bit spoiled as a physicist because I feel as though I assimilated a lot of critical thinking skills from our training, because we have a lot of, you know, this first principle type of training. So that, in my opinion, that leads very nicely into, or moves laterally very nicely into like thinking about thinking and kind of the critical thinking aspect. But I'm just curious as to like the average person, what are your thoughts on them being able to develop some of these critical thinking skills? Again, we're spoiled as somebody that has gone through not only higher education, but the physics in particular with the first principles thinking. But, you know, we both admitted that this isn't something that you learn in the public education system. So the average person, how can they, like, what are your thoughts on them being able to assimilate some of these skills? Where should they look? I mean, I guess I have a platform, but yeah, I mean, what are your thoughts on that?
Well, in some sense, I think on a systemic level, it's practically hopeless. But I think it's more like you can maybe reach individuals one at a time and try to move them slightly ahead. So like there's this theory of moral development by Kohlberg, which was like one of the first models I saw for that. Where the trick in terms of talking to people is never to sort of like engage them too far ahead of where they already are. You always have to be like just slightly one step ahead, talking to people. So for example, the majority of people morally are just trying to be sort of nice or fit in with what their sort of tribe or the people they identify with think about certain matters. Morality is defined by what my in-group thinks, right?
Yeah.
The next level beyond that is going to a more legal framework where what is moral is what the law says. So I'm not just trying to be nice, I'm actually trying to obey the law, and if that means me not being nice, then I'm not going to be nice because the law is the law. So if you want to move someone from sort of like the being nice to the in-group perspective to like, we do this because it's the law, then you have to sort of like create some cognitive dissonance in terms of like, what are the situations where being nice does not actually create a moral outcome or an ethical outcome. Similarly, there's a level beyond that, which is sort of like the societal level, where people begin to realize that the law might not be sort of like the final word in matters, that people actually vote on what the law should be. And so for someone who sort of like sit in, well, the law is law because it's the law kind of thinking, you have to put in sort of like steeped doubt in terms of like, why is the law the way it is, right? It's just the same thing, like, so I know you wanted to talk about this, if you go to like social media and Facebook, especially Facebook and YouTube, and also like Google searches, where things are presented to you for like maximum emotional engagement, recurring engagement, rather than actual truth. You have to, there are a lot of people like interacting on those networks who think they are well informed because they read everything in their feed, and that they have thought about that critically, because if there's something they're in doubt about, they just go and Google it, and then you find some web pages that confirms it. So now they think they have like done their research, right? The way to sort of like get out of that loop, which is obviously not thinking critically, it's just sort of like essentially regurgitating what the algorithm is feeding, is to begin to ask, why do you think your Facebook feed is that way? Do you think your Facebook feed is the same as my Facebook feed? Or do you think it's somehow different, right? Or do you think your Google results are the same as my Google results for the exact same query, right? So at each and every sort of like level, a stage of insight, there's a stage beyond it. So in order to move people to the next stage, you have to sort of create a dissonance at their current level. and then let them themselves come to a conclusion. Well, maybe I don't know everything. I think like the most dangerous thing here with say thinking or critical thinking or any kind of badge is that declaring oneself, well, I'm a master of critical thinking, say, so I don't have to think about this anymore because I already know.
Yeah, no, that's a dangerous trap. Yeah, that's a dangerous trap.
Yeah.
Yeah, I do.
Yeah,
I think it's like learning the critical thinking, what you're just talking about, that even though you may have a PhD or you may engage in reading books regularly, for you then to declare yourself that you know everything is ridiculous.
Yeah.
Because you just can't know everything.
Like, yeah, I mean that's actually a very strong physicist trap. So I saw a cartoon once, like once you're a physicist over the age of, I don't know, 40, 50 or something like that, then you should probably be put down for your own good, because otherwise you start speculating about all kinds of things you have no idea on and think you're actually good at it. That I think so like if say like you have a physics background, you're very good at like dissembling things and figuring out what the structure is, but that also makes it very tempting to try to do the shortcut on all the technical work, all the copying and compilation and you know, derivation and pushing things around, all the parts that go into things. Just skip that part. Well, I already understand structure, so I can easily go over and do biology. You do have some advantages as a physicist, but you're probably not as good as a biologist who came up from the ranks in that regard.
Yeah, that's just pure arrogance. Then I think it's
very arrogant. I mean, yeah. No, that's definitely a kind of so. I mean, but we also know that arrogance is there, right? So we try to correct for it. So that's. I mean, it's kind of like the Dunning-Kruger thing. Is hopefully you're on the right hand side of the graph, not the left hand.
Yep. I'm well aware these days of how much I don't know, which is terrifying, because as somebody who is very educated, I mean, I don't feel bad saying that at all. I spent a long time learning things, learning about the world, and because of that, there's a profound sense of humility that comes with it, because you become intimately aware at some point of how much you don't know. But what scares me the most is looking back at my youth about how confident I was in certain things, right, and that a lot of people are stuck there, and then they never move beyond that spot. And they walk around with this just astronomical level of confidence in how the world works. And because they are so confident in whatever it is that, you know, they're professing, people will listen to them because people latch onto that confidence. And it's usually, I would say it's usually, it could be very, very, very wrong.
Yeah, and because people can't tell the difference often.
And then there's that. Yeah, and there's that. They're like, oh, I don't know. This person is incredibly confident. Therefore, you know, perhaps they have like some letters after their name, or the way that they're dressed, the way that they look. All of these things factor in. Right. And then you have, for example, now we have an epidemic of like fake experts on YouTube, or, you know, with Instagram influencers who are promoting nonsense products, but they're beautiful people. So therefore, they must know what they're talking about because they're beautiful people. And we know that people are attracted and will think that more physically attractive people must be telling the truth, or they're more likable. So therefore, they're telling the truth. And this just isn't the case. I'm not saying that it always happens, but you know, going back to the Dunning-Kruger, it's crazy.
So two things. So I've definitely noticed the same thing in myself, that I was more confident 10 years ago and 20 years ago, and I now, because I know a lot more exceptions to things. Back then, I would just say, well, this is the way it is because like I derived it, right? I pushed my equations around. But now I see all the exceptions, and sometimes that can be somewhat stymieing in terms of what I'm willing to say about something, because I know there's more to it typically. In terms of like people not being able to tell the difference, I spent a lot of time, maybe way too much time, like on climate science and climate wars. And so, as based on my background, which was like hydrodynamical simulations on the surface of neutron stars doing chemical reactions there, nuclear chemistry. That is, the structure of that is practically identical to what you find in a general circulation model on Earth. So I know a lot of what goes into a climate science model. I'm not an expert, but I know a lot about it. But I spent hundreds of posts arguing, like long posts on my forum, arguing with people who would Google something and so like, what about it's the sun, and what about, you know, like, it's the new ice age, or all that kind of stuff. And the problem there was that most people would see that as a debate between two equally informed. Like, I can't tell the difference, right? That's like a layman.
You're talking. Yeah, well, you're referring to false balance, right?
Yeah, exactly.
Yeah. But yeah, it's at the same time, it's so difficult because it's like, do you just let these people spew their nonsense? Because then there's other people saying, well, okay, this person is presenting this. Maybe they'll go read it. Maybe they'll think that that person who made that original post is an expert, and then they'll start believing that. So it becomes difficult. Like, how do you even deal with that?
Yeah, I think I succeeded. I mean, so after many, so we're really talking like hundreds of posts, like the longest threads ever on the forum I hold, where I would sort of refute these points one by one, you know, like, here's a new, but okay, I will sort of like give you the benefit of the doubt that you're not some kind of troll, which often they are, and then like refute it point by point, and that never works. What finally worked was me spending, I think it was like 4 hours one morning, building a sort of like an entire layered atmosphere model from scratch, like a slab model essentially of the atmosphere. And then showing, okay, I know what I'm talking about, what these guys are objecting to. So that was, I think, something like 17 steps. First you do this, first you do that, and then you do that. And then it became clear to sort of like the audience that, okay, maybe Jacob knows what he's talking about, and the other guys just sort of like Googling random words he just read. What I found practically impossible, except very few exceptions, was to get people to read even like chapter 1 on like an introductory climate science book. Because a lot of this was essentially like basic stuff. I mean, a lot of like the objections of denialism are legit in a sense that they were presented like 150 years ago or 100 years ago, and by legitimate scientists, but then quickly refuted and forgotten. So radiative saturation, right? So I don't know if you heard that argument, and it's probably knowing sort of like about brain weaknesses is a little dangerous to repeat it, right? But if you take a gas tube and because people might think it's actually an issue, right? If you take a gas tube and shine light through it, right, the gas in it will absorb certain wavelengths, right? And that's how you get an absorption spectrum. And if you increase the density of the gas, then at one point you will have essentially taken away that entire wavelength, right? And so the argument was like, at some point, if we keep emitting CO2, then it's not going to matter anymore because
we're just going to be blanketed in a CO2 smog.
Right? No, because the saturation is complete, so adding more will not stop further.
Oh, I see. Okay.
And actual physicists, like real life physicists of even some fame, and I'm not going to mention anyone by name here, but yeah, there's been a couple out there, but who have like apparently no knowledge of what happens if you're no longer looking at a gas tube in a lab, but actually looking at the entire atmosphere, where you also have where the Doppler shifts of the moving particles in the gas become relevant, how that would increase the absorption spectrum. So they would not know that because they have no domain knowledge of that particular aspect of the physics, but still they would sort of like argue with the authority of the physicist.
Well, and this is part of the problem, you know, with the global warming thing, is that you do have experts that aren't necessarily domain experts, but they carry credentials like a PhD after their name. And then they are so arrogant to think then that, okay, well, I'm going to challenge the domain experts, even though this isn't my area of expertise. And, you know, as much as you should respect that individual for whatever their area of expertise is. But when they go outside of their domain of expertise, you should then be skeptical of what it is that they're talking about.
Yeah, they're just sort of like maybe a possibly well-informed or maybe even like a misinformed layman at that point.
They're not going to know. Yeah, and it is still shocking to me to this day, the number of people that will not acknowledge anthropogenic global warming. Even though we have a scientific consensus surrounding it, it's like somewhere around 97%, they say. But above and beyond that, then not only do they acknowledge it, but then they don't even know what a scientific consensus is in the term of what consensus means when you put scientific before it. So for example, consensus, when you use it colloquially, the average person thinks, oh, like it's just a group of people agreeing on something. But in science, it's very specific. It means that all of the data, not the scientists, it's all of the data, the collection of all of the evidence, the science from all the different sciences that studied, in this case, the atmosphere. So, you're talking about chemistry, you're talking about geology, you're talking about maybe even geography, you're talking about physics. And then all of these studies collectively over decades of work from thousands of scientists across the planet, it all points to the same conclusion. That humans, but they don't realize that either. That's something that's not communicated in the public education system, maybe even in college as well. There is a real disconnect these days in my observation between the work that scientists do and how the public perceives the work that they do.
Right, yeah, and I think a lot of that comes from sort of like how scientists are also portrayed in TV or movies, in the sense that you just write a bunch of equations up on like a glass wall or something, and then you solve the whole thing in an afternoon.
Yeah.
The institutional knowledge and they don't show the library with all the books supporting everything that's being written up there on the board. So the confidence is not shown, just sort of like. But I find that frustrating, and I think that's also, kind of goes back to my idea of a scientist as like a naive 18-year-old was actually kind of like that. You just have you have some kind of glimmer of insight, and you just write down some equations, and then you prove the Nobel Prize or something. But that's not how it works at all anymore. Or if it ever did, it's kind of like you ask the on your high school tests, so one of the questions like, what is the scientific method? And it has some kind of clear step-by-step hypothesis verification, hypothesis experiment verification or rejection, right? But doing real science, that's generally not how that works at all in my experience. And I don't know if you agree with that, but it's a lot more sort of like a circular thing. You try.
Oh yeah, absolutely. It's very cyclic, and
it's not like we aim to prove or disprove this exact thing, and now we're just gonna go like straight from here to here.
No, that how they present the scientific method, I suppose, in an educational context is not entirely how it's done in practice. But I think, in my opinion, though, I think the simplified step-by-step does do a good job of communicating what exactly the scientific method is. And even in that simplified form, I think it still does a good job of communicating to people that it is a method. It's not a belief system. That it's some sort of rigorous framework that we have developed in order to try to learn something novel about the world.
Yeah, but I think, at least the way I was taught science, and that was again sort of textbook problems and essentially known experiments, which say like a falling ball, like distance equals half gravitational acceleration g squared or something like that. So it was something like set up an experiment that verifies this, right? It would and that follows the scientific method exactly, right? Here's the hypothesis, like S equals half AT squared, and then you plot something on a graph and you fit the graph, and then you get maybe the gravitational constant out of it, right? Yep. With some uncertainty. But in reality, the question should more be like, what is the actual equation for the trajectory of the falling ball? And that might have been something completely different depending on what kind of experimental setup the students have come up with. So a lot of the creativity is essentially taken away in the school setting in order to sort of like narrowly funnel people in towards a certain conclusion. You see what I mean? So the critical thinking aspect is taken away in the teaching setting, I think.
Yeah, and that might be due to time constraints, because I know for, let's say, for example, if experiments were completely unconstrained, it would probably, I don't even know if students would be able to finish.
Yeah, it took an entire year just
Yeah.
to figure that stuff out. But the question is, would you learn more or less doing that way?
Yeah. Yeah, I know. It's a very interesting question in pedagogy. How exactly should you teach in general? Like how is it best to teach this material to students?
Yes.
And going back with the critical thinking stuff, I think that the students would probably pick up more if they had to think harder about certain problems.
Right.
But due to
students, right, that a lot of them just sort of like ask the smart one and then copy what they know, right?
Yeah.
Yeah, you probably happened to you too, I'm guessing.
Yeah, I mean, I'm not going to sit here and say that I was the brightest physicist among my peers or anything like that, but I certainly tried to do as much work as I could on my own. And I don't know about, I worked a lot, like particularly in graduate school, we worked a lot in groups, just because the material becomes so complicated that it's just easier to work in groups and to bounce ideas off each other. In particular, particularly like when I was taking theoretical physics courses, like general relativity, like I had like a core group of people that we would get together and work on the homework sets, just because they were just very hard and long. But, earlier on, in grade school and throughout like middle school and high school, I mean, I suppose I let people copy when when they needed to. You're just trying to fit in. We were talking earlier. We were talking earlier about the social aspect of an educational setting, and that people in general want to try to fit in and to be liked. If you're kind of a little bit more nerdy or whatever, you kind of let people copy because then they like you. So
and that's sort of like part of what sort of moving one level up from like the individual setting. The institutional setting also has to account for that effect, right? When they try to teach stuff, and from like the institutional perspective, they might not be so interested in sort of like turning out people with a great understanding of the scientific method, just to pick that one, as they are in sending people on to the next institution, right? I mean, that seems to be sort of like an increasing problem now, where the motivation is to get more and more people into higher education, or tertiary education. And because humans are not getting more intelligent, that means that if you want like 70% or 80% into college as opposed to say 40%, you have to reduce the level somehow. And if you're not doing that fast enough, then people come in without being able to catch on fast enough. So now they're remedial courses, right? So
yeah, no, I understand what you're getting at. Yeah.
So now I forgot what I was getting at. Shit. But then, the point is that the institutional system might not, so the anthill might not have the best interests of the ants at heart, the individual ants at heart, but it does have the best interest of the anthill itself, even if the anthill is not sustainable or whatever.
So, yeah, I totally understand the point you're driving home, and talking about whatever the system and education, you made the comment earlier that you think that on a systemic level that critical thinking is hopeless. And I'm curious if you believe that it's hopeless because the system doesn't want it, or that the people who are within the system don't want to be taught this, or that they'll be resistant to it, or perhaps there's some other reason. I'm just really curious as to what your thoughts are, because I've had conversations with other people who think that from a control standpoint, if you're trying to run a society, that having people educated beyond a certain point isn't actually advantageous, that they become too recalcitrant or challenging or something of that nature. I didn't agree with it, but I've heard these arguments made before.
Yeah,
I was just curious.
I could definitely see that happening. I mean, it's kind of hard to get me to work for something anymore. I mean, I'm not really motivated by money, for example. So I could see people getting too educated for their own good. I mean, but that depends on that depends on what kind of system or what kind of society you want at the final, at the final level. If you want essentially like an extractive civilization or an industrial civilization, then it probably makes a lot of sense that people are not too smart and they work very hard, and that they're motivated to do so by essentially being indebted, paying off loans, and occasionally getting that dopamine rush from buying something new. Because if they don't get that, they will definitely not work as hard as they currently are. So in that sense, if we imagine that powerful people are pulling the strings on society and optimizing for that, then education is beyond a certain point is a bad thing. And specialized education is almost like a divide and conquer thing. Well, you might be overly educated, but you're really not, because you only know that one thing, right? Whereas the rest, you're like barely functional at all to cannot even start a fire or explain how the microwave oven operates beyond the button pushing.
Divide and conquer, critical thinking into education, people being overeducated.
Yeah. No, I remember what I was saying. I just don't remember why I was saying it.
Well,
go ahead.
ahead.
I remember. So like it's kind of like the same thing when in terms of like when politicians occasionally looks at like population and fertility, for example, where the point is like if we don't have enough children, then like we being sort of like the far-sighted pullers of strings on the general society will run out of either consumers or workers who are paying into social security for the increasing elderly burden, or soldiers, right? So they're kind of doing it for the good of the system, but they're not going to do it. They're not doing it for the good of those who are about to be born, in that sense. So I don't know if there's some kind of master plan going on like that. It sounds sort of like a little. I mean, I'm sure let me put it another way. I'm sure some people think like that. If you're some kind of industrial magnet, you would certainly promote things that are good for your business, because you know that your business or corporation might live for 200 years, as opposed to those who work in it. So you're sort of like working for the institutions. Whether this is being done deliberately or whether it's sort of more of an emergent structure or emergent feature of the way things are currently organized, that's more what I would lean towards. Can't really say. I mean, all from my perspective, I'm sort of more inclined towards sort of like the individual practical solutions, in terms of like, well, let's use our physicist's mind to take the system apart and then find a solution where for the individual, for those who want to take it, right?
Yeah, it definitely has to be like a grassroots movement. So teaching the individual how to kind of move away from these things. And going to your point of whether or not it's an emergent phenomenon where we're at now, if it was something that, where you have like these architects. I think that perhaps it's a little bit of both. When you're talking about emergent, like it arose because there were architects along the way that were directing capitalism in the way that it works today, where with this excess consumerism. There were master marketer psychologists. There's one, I think it was Edward Bernays in the early 1900s. He is a brilliant mind. I think he was a cousin of Freud or something like that. But he went into corporate America, and he is essentially devising marketing campaigns to get people to buy products. And you still see this happening today, where people are using cutting edge psychology in order to get people to do things. And a lot of that is just this capitalist system of consume. So whether or not we want to admit it, there were architects who crafted our society over the past 100 years that we are now living in today. And going back to whether or not this is a good or a bad thing, when it comes to people being educated, particularly in critical thinking, I do not see human beings surviving sustainably with the current system.
No, because the current
Yeah,
system itself is not
the current
sustainable.
system is so messed up, and if the current system forces us as a society to train people to be wheels or cogs in a larger machine where all they do is go through this wake, work, consume, or buy things cycle on a daily basis. I don't see how that is going to lead to a long-term human civilization. I just don't. And from a happiness standpoint too, I don't think people are happy doing that. I don't think that
I mean, you can
fulfills.
see like the sort of like the happiness indices,
Yeah.
they're like flatlined for years, if not decades, and you can even see it on like the spending curve. The Easterlin paradox is that economically you would expect that happiness versus consumption, right, would be like a straight line up, but it actually like
it tapers off after. And when you talk about like income level two, beyond a certain point, they've studied this. It falls off exponentially, where you get diminishing returns, where like above beyond like 70 or 75,000. Again, that depends on how you want to live, but I guess for the average American, if they want to live in a home or whatever, and they want to have a car,
it's generally set at like two-thirds, sort of like a third over the average income or something like that. So everybody wants to be like slightly better than average, no matter what the average is, beyond like a certain very, very low point. So,
but going into the minimalist, the early retirement extreme, if you're able to reduce your overhead significantly, then you can get to that point very quickly, where you make enough money, and beyond that point, because you're so minimalistic, it's not going to make you any more happy, and then you can go and spend your time doing whatever it is that you want to spend your time doing, whatever fills you inside.
Yeah, and especially if you're like widely competent in various skills, you can like stretch dollars in many different ways. Not only do you have interests that are uncorrelated with spending, but you also have ways of reaching that happiness points a lot earlier, right? I mean, so as a household here, we spend about $14,000 a year per couple for two adults, right? But I will estimate that our standard of living compared to our neighbors is just more sort of like in the $50,000-$60,000 neighborhood, which means that we are getting like 4 times as much out of each dollar as they do. That also means that we are spending our money much differently than the average consumer if you look at what kind of products we buy or what kind of services we consume.
Yeah. Well, I mean, as far as problems go for humanity at the moment, Jacob, for me, like I'm really concerned about global warming. That really concerns me. I'm very concerned about polarization here, particularly in the United States. And then I think that and this is beyond the United States, this is again a global issue, but if you're talking about like first world, or not even first world, but like just capitalism in general, I think capitalism has done wonders. I think that's undeniable, but it has, particularly here in the United States, it's kind of morphed into this this ugly creature that is not sustainable in the long term. And what we need to do is figure out how to take the capitalism and turn it into a sustainable form of capitalism, where you have like free markets and things of that nature, but we're able to figure out where we draw the line and what's reasonable and what's not. And I don't know how you do that, if that's through, if that's going to be through the nonprofit sector, if that's going to be through new businesses that I don't even know of. If it's a fundamental shift in governing, for example, like more regulation or something of that nature. I'm not exactly sure how you solve this problem, but I do know one thing, that the grassroots movements of getting to people and trying to tell them that they are more than what they consume, and that you don't need all of this stuff to make you happy, that this philosophy will lead to long-term sustainability for the planet.
Yeah, I think
people really need to detach themselves from this idea that they've been indoctrinated with, and that we've promoted, at least here in the United States, and I think this happens in other capitalistic nations as well, for the past 100 years or so.
I think I sort of agree with that. I mean, I think that's the only way I found that I could imagine that would work going for people as individuals, and then creating sort of, I think it's going too slow. I don't think it's gonna be done in time, but I think it's the only way. Creating enough individuals who are actually free to choose their own minds. Let me rephrase that. That actually has the liberty to live in a different way, have the freedom to live in a different way. Because if you go to sort of like a random person who are sort of like deep in their careerism or consumerism and tell them, well, you have to live with an ecological footprint or resource base or pollution limit that is like 4 or 5 times lower than you're used to, and they'll tell you, well, that's impossible, that's too extreme, I cannot do it. So in order for me to actually even begin thinking about that, we need to elect some politicians who will do some kind of top-down thing, or we need to convince the corporations because they're like the evil ones or something. So I think that's essentially where that's essentially like currently the system is trapped because they don't know any other way than to solve problems at the institutional level. And the current institutional level, for example, with global warming, is stuck at the national level, but it cannot be solved at the national level, right? I mean, you saw that with the Paris Agreement that kind of fell apart. We don't know if it's sort of like on again on January 24th or whatever, or whether it will stay off. Sort of like a top-down solution for climate change would almost require sort of like global coordination. But we are very, as humanity is very poor at global coordination of something like that. So the only other alternative is to create individuals from the bottom up in that sense.
A grassroots movement. And yeah, and like you said, like on a governmental level, it's seemingly been impossible. And but what gives me a little bit of hope is the Montreal Protocol. So we did come together for the ozone hole with the Montreal Protocol.
That had like a simple technological solution where you could just tell like one company, I don't know, was it DuPont or something else, say, okay, and we already had a replacement.
Yeah, it was a much simpler problem. It was a much simpler problem, absolutely.
CO2 is way
bigger.
It's in everything almost. And if it's not CO2, then it's methane. That's in the very things we eat, right? Yeah. That's those are not sort of like a difference of degree. Those entirely different problems.
Okay, that's fair. That's fair. There was global cooperation though, and for something environmentally related, which why global warming, I have a little bit of hope of the global cooperation again, but you know, as we just discussed, I mean, global warming is incredibly more complex than what happened with the ozone layer, or the ozone hole over Antarctica.
Yeah, I mean, with global warming, it took I think the Charney report in '79 is essentially what the current level of understanding is in terms of accuracy. And then it took 13 years until we had the first international conference in Rio, essentially. And then it took another, 2015 or something, where you had the first global agreement that we should agree on something. That was the Paris Agreement, so it was not binding in any way. And so getting to the next step from that, you know, it's just moving too slowly with sort of like the current technologies of international collaboration on the nation state level. From a scientific perspective, I mean, and I don't know if there's a sort of like a sociological or political solution to that, but I think a lot of scientists in that regard is sort of punching on that, saying it's not our problem. Or rather, what's really happening is that the two different camps, the STEM camp and the poli-sci camp on the other side, are hoping that the other side can somehow solve the problem. So, like from a political and economical and financial and cultural, those people who are sort of like steeped in that, they're kind of hoping for a technology solution, like green tech or something, that someone will come up with something fancy. Right, something that will solve.
Technology will save us.
And on the STEM side, it's kind of like, well, we probably will not be able to do that, but you know, if you guys on the policy side can just sort of like agree that we reduce everything by 5% emissions by 5% per year for the next, you know, like 3 decades, then that too will resolve it. And of course, on the political side, they know that nobody can agree to that. So we're kind of stuck, right?
Yeah, no, it's like you said, it's just not moving fast enough, and
Yeah,
we are not making the changes on the timescales that the changes need to be implemented in
right,
order
right.
to in order to avoid some of these really bad scenarios when it comes
And
to the
part of
climate.
this because the sort of like the generic human is, I mean, we're still operating essentially with the same hardware
Yeah,
as we were 50,000 years ago, and we're sort of like the average time horizon is something like maybe next Friday, if that, right? And so the average concern of what the future goes out for a few days to a month maybe. And average concern for other human beings goes not much further than, friends and family, possibly to the entire country or your local club, you know what I mean, right? So like the Dunbar number essentially is
yeah,
what
the
we
Dunbar number, like 130 people or something like that. Yeah,
the number of people we're not really concerned about. I mean, we might express some concern about people on the other side of the planet, but in practice, we're not acting as if that is a concern. And similar with the time scale. So our sort of local space-time bubble as a Neolithic derivative is very tiny. And we simply do not have we don't really tend as sort of like a species to process beyond that, and that is what is required now. And since we're
we
not
need. Yeah, when you say it's required, yeah, we need to
yeah,
start thinking.
yeah,
We need to start thinking in systems thinking and on much larger scales than we currently are.
right,
And
yeah,
it's not something that we do naturally, but it's something that we can teach people.
yeah,
I think it would be very easy to implement it or incorporate it into the public
yeah.
education system.
Yeah, I mean, I think
So
we can teach people the ideas in the abstract, but can we teach it in a way so people also like internalize such behavior? That I am less certain of.
yeah, I'm not entirely sure.
It's kind of
I had an interesting notion years ago of maybe trying to harness the overview effect on like large scales. I don't know if you're familiar with that, the
no,
overview effect. So
no.
the overview effect is something that astronauts experience when they see the planet from space,
Oh, okay, okay,
that it impacts them on such a profound level that
right,
they
right,
feel this sense of connectedness to
yeah,
the
okay,
planet, to each other. Like you don't see different countries anymore. There's no boundaries, and
right, yeah,
that you come back to Earth with a
yeah,
sense of like how precious the planet is,
yeah.
and that we're one human race and all of this. And yeah, I had the notion that perhaps maybe something like a technology like VR or something like that could be harnessed.
I think on a simpler level, I
Yeah.
mean, just having people, I used to hate travel, or argue strongly against travel, probably because I did a lot of it in grad school and as a postdoc, and I was just sick and tired of it. But I've sort of come around on that, thinking that like going to other countries and not as a tourist, but actually living there,
Yeah.
or inside the U.S. living in other states, but not just moving to your sort of like your own in-group, a tribe in another state, but actually living with other kinds of people and other cultures are
No, I
part of
agree with
that
that. No, yeah.
kind of overview. I mean, and then the thing like going to college might not be so much about learning a bunch of technical stuff, pushing equations around. Might be more about living on your own as like a sovereign individual, more or less, compared to when you were like a child living with your parents. And if you do that out of state, I mean, there's a lot of things you have to learn faster, like organizing your own laundry, that kind of stuff, right? Making sure that there are actually groceries in the fridge yourself. It's pedestrian and simple stuff, right? But doing
No,
these,
yeah.
and that's just sort of like the very first step. You can go much farther and like move to another country. Or you can move to I mean, okay, I'm kind of arguing in distance here. I think the experience in doing something that you're not normally doing is more valuable than doing just the same experience in another country. So the other important thing is I mean, not only trying to live in different countries or trying different locations, but also trying to live on like different budgets, different situations, different income levels, and then it becomes a lot clearer of how different people are, because there's like really a tendency to only see one's in group, especially if one spends a lot of time in that group. And yeah, I think, I mean, if there's a technological solution, I think actually the world is kind of moving in the wrong direction in that regard, because say if we return to sort of like the Facebook Google thing, where the technology is such that it tends to create filter bubbles, right, where the in-groups shrink more and more and fracture, because that allows for a lot of engagement. I don't think it's surprising that it's happening that way, because it's essentially reinforcing our nature. What effective technologies should do would essentially be to like resist our sort of like Neolithic.
Yeah. No, yeah, it definitely, that aspect is definitely moving in the wrong direction by keeping us in our bubbles. And I mean, there's evidence we're becoming more polarized because of it.
Yeah.
And you're talking about our brain, how our brain is not evolving at the same rate as technology is.
Right.
You have these things moving on exponential trajectories, maybe even super exponential, and we're still thinking linearly. Our hardware is not updating. And if you look at how we responded to the COVID response, at least the public, when you're talking about exponential trajectories, it's been, at least here in the United States, it's been pretty bad. Some countries have been much better at it than others. Here in the United States, not good at all. But like I look at this and then I look at global warming, you're moving on the same exponential trajectory, and people just cannot seem to understand the urgency of doing something because they don't understand how to think in exponentials. And
I kind of saw COVID as sort of like a trial run to global warming.
Yeah, a little bit, right? Yeah, a little bit.
If we get this right, we cannot get global warming right. And on an individual level, it's something like diabetes or heart disease and all these lifestyle diseases. Like something like 60% of Americans die of the preventable lifestyle diseases. It's simple stuff like eat right, move regularly, all that kind of stuff. But our brains can't even get that right on an individual level. So like this, it kind of makes me a little hopeless.
Yeah, I was super optimistic when I was younger that we would figure this out, and I really wanted to be a part of the solution. I still want to be a part of the solution, and it's something that I continue to work on. But the more that you understand the problem, it does just seem like it's like a Sisyphean type of effort, where it's just like you're never going to be. You keep pushing the ball up the hill, and then it just rolls down again, and you just don't make any progress whatsoever.
That's why I dropped out of physics, actually.
Yeah.
Because I had started my blog around my final postdoc, and I was beginning to notice that I was actually getting more feedback and more engagement, so to speak, on the blog than I ever had been in my physics work. When I did like my initial sort of like intro week at my last position there, we talked to an admin, and he revealed that he was like a former physicist at that lab, and I don't know if it was me asking him or someone else. So like, why are you an administrator now? Well, he said he wanted to do work that was interesting to more than 5 people in the world. And I was just like, FML, right? Okay.
Yeah, right. Yeah. No, I can appreciate that, and that's it's part of the reason why I moved away.
I gravitated towards this more like applying physics skills to like how to live a more interesting life, your personal life instead. I mean, it was the same thing. I along with the anti-consumerism and sort of like this whole mortgage saving business. I was also very much into the peak oil movement at the time, around that time in the 2000s. And I found that most people really did not want to talk about that stuff. It's like, please stop talking about it, Jacob. This is too depressing. I don't want to hear about it anymore. So there's a huge stick our head in the sand effect on people. There's very few people who actually like to hear that things are not well in the kingdom. And so in those regards, like, so what are the solutions there? Like, you could do energy research and find a new energy source, or you could also go in the direction of trying to educate people to like use the existing energy better. And I found that my strength was essentially in trying to communicate, trying to sort of bridge this kind of complex understanding of the world and translate it into some more sort of like individually actionable items or individual actions. So that's essentially what I ended up doing. I mean, it's very, very hard to escape that now.
Well, no, I mean, I certainly can appreciate it. I know how esoteric physics can be, and particularly when I was working in theoretical physics, it felt so detached. And the work that I'm attempting to get involved with now is more in the urban sciences and trying to figure out how to make cities more sustainable, since we are becoming an increasingly urbanized society. And that's still a bit detached, but I think it's more applicable to what's going on in the world than obviously high energy theory. And then I started my blog, Intelligent Speculation, which I wanted to morph and more into like an educational platform, which it has over the years. But that is my attempt as well to reach out and to connect with people and to try to get them to think a little bit more about why it is that they believe what they believe, and how it is that they come to structure their thoughts and how they are influenced by information. How do you even go out and in the world when you are just bombarded by all this information today through all these smart devices and discern what is fact from fiction. But yeah, it's certainly interesting times. I mean, I'm not a complete pessimist. I still am holding out hope that the bright minds will come together and that there's enough good in the average person to want to kind of solve these problems, because I think for a species, this is a make or break century for us. You're familiar with Fermi's paradox? I'm assuming as a physicist you are. So Fermi's paradox, for those who aren't familiar, is the idea that the reason why we don't see intelligent life anywhere else in the universe is because there's some sort of great filtering event that intelligent life can't seem to get beyond a certain stage. And this century, I think, is our make or break point. I think for us as a species.
Whether we can escape our own pollution.
Yeah. And I don't think leaving the planet is the answer. I really don't. I mean, I don't see that being, at least in the immediate future.
You must have to run fast enough then. I mean,
yeah, I just don't think.
Mars, right? We'll screw that up, right? But then at some point we run out of planets in the solar system and going to another star system.
Yeah, we need to move beyond. Yeah, we need to move beyond this sort of cancer type of model relationship that we have with our planet to one of like a probiotic, where we have a symbiotic relationship with our host. And we currently do not. We have more of a parasitic relationship with our host, and we need to move to the symbiotic one. And that transition needs to happen rather rapidly, and we'll see if it can happen. I'm not entirely sure, but I'm hoping that critical thinking, and your philosophy as well, will play a role, on an individual level, trying to get people to adopt these philosophies, to live minimalist, and to understand how it is that they come to structure their thoughts.
Yeah, at least we tried, right?
Yeah, right. But anyway, Jacob, I think this is a great point to stop. I just want to thank you again so much for agreeing to come on. It's been an incredibly enlightening chat. Very, very wonderful overall experience. And for those that are tuning in, I mean, are you active at all online? I mean, you still have your blog, it's up and running. Where exactly can they find you?
I'm highly active on my forum, but that's about the only place. So
okay.
So that's sort of like of the if you can find it challenge level.
Okay.
Because that kind of keeps the level high, I would say. If people want to make the effort to actually go and find me, that makes the experience.
Well, I'll definitely make sure. I'll definitely make sure to link to your blog in the show notes. And if you want to engage with Jacob, then you can go on a hunt for his forum tab, which you'll find in there. And then your book is available, obviously. So Early Retirement Extreme, it is available on the website, and then it's available, I'm assuming, on like Amazon and other platforms as well.
That's a paperback and Kindle, and we just had an audiobook come out as well.
Oh yeah, that's right. The audiobook's available now too.
Yeah, it came out like a couple of weeks ago. And then there's a wiki that's being developed as well. But if you find the blog, those are all linked in the top of the right sidebar.
Okay, fantastic. All right. Anyway, thank you again. And for those of you that are tuning in, definitely make sure to like, to share, leave us a review, let us know your thoughts. And it's been wonderful. Can't wait to bring some more quality content your way. Until next time, and take care.